Hello everybody, so for this video I'm going to be teaching about limits that don't exist. So the three types are unbounded behavior, oscillating behavior, and behavior that differs from the left and from the right. So let's look at our first one. So the first one we have unbounded behavior. So let's first look at our equation. So you have limit of x approaching 0 and 1 over x squared. So if we put this into a graphing calculator or graph it ourselves, we'll have something that looks like this. Our graph right here on the bottom. So if we look at this, we can see that x or f of x always increases with that bound. So that means it'll never hit 0. And we can do this by plugging in numbers for x. Just say we plug in, so we can't plug in 0 for x, or that makes it undefined. So we can plug in something like 10. So we can do 1 over 10 squared, which equal to 1 over 100. And that's not equal to 0. And no matter how high we make x, it'll never hit 0. So we can do something like 1 over 1 million squared, and that'll equal to 1 over 1 trillion. And that's still not equal to 0. Even though it's really close, it's still not equal to 0. And we can do something like 1 over 2, and you'll get 1 over 4. So that's not equal to 0. And even if we go negative, like something like 1 over negative 10 squared, that's equal to 1 over 100, which is still not equal to 0. So that's something called unbounded behavior. So let's look at our next one. So for this one, we have something called oscillating behavior. So there's not really much to it. We have an equation which is limit of x approaching 0 and sine of 1 over x. And if you try to graph it on a graphing calculator, we'll just get into like this. So this behavior right here is called oscillating behavior. So just you can see it like goes up and down, up and down. And this one also fails to exist, this limit. So let's look at our next one. So this one is behavior that differs from left and from the right. So let's look at our equation. So we have limit of x approaching 0 of absolute value of x over x. And if we try to graph it, we'll get something like this. Where as x approaches 0, there's both a positive value for f of x and a negative value for f of x. So that means there are two different limits, which means no limit exists at all. Because there's one value right here and one value right here. So that means it fails to exist. Thank you for watching. I hope you enjoyed this short video about limits that don't exist.